locus of parallel chords is diameter. Okay. So if you have been given a hyperbola x square upon a square minus b y square upon b square is equal to 1, and slope of parallel chords equal to m. Find equation of diameter of hyperbola h. This is h. Okay, the equation of diameter is y is equal to b square upon a square m times x. Okay, we have done this in ellipse, so we should be able to do it in hyperbola. Two diameters are said to be conjugate with respect to each other if and only if each bisects the chord parallel to the other. So what is the condition for two diameters having slope m1, m2 being conjugate diameters of each other? So condition is very simple. m1 into m2 times a square. Easy. Okay. Now, this is what is the condition. So now it is important in case of hyperbola to figure out geometrically what do we mean by this. Now, in parabola, in ellipse, we could actually see the conjugate diameters. Now, we have a feeling here because we are drawing using freehand. Suppose we draw parallel chords. And we locate midpoints like this, something like this. Then because we are drawing it using freehand, this diagram is going to mislead. We will feel that this is our corresponding diameter. It now intersects over here. So this was a tangent at this point, and maybe corresponding tangent somewhere else, because it is going to be a this is C. Suppose this point is P1 and suppose this is P1 dash. Then unless and until we draw this hyperbola to scale, we won't be able to imagine the conjugate diameter, because practically we are drawing this as a parabola and we are getting the locus of the midpoints, which in actual case is going to be very, very difficult to get. I mean, you will get the locus, but okay. So what is the slope of conjugate diameter that we are getting? Suppose what is the slope of diameter m here? These lines y is equal to p square a square m times x. So what is this is the equation of diameter. Okay, this is the equation of locus of midpoint of parallel chords whose slope is m. Okay, so now this is going to be very important discussion here. So before that, let us do some work on quadratic equation. Say for example, if I want to say that y is equal to mx plus c, it's supposed to be tangent to any degree to curve. Say y square is equal to 4ax. Okay, then in that case what do? We solve these two simultaneously, and we want this line to be tangent to this parabola, and therefore either we go for delta is equal to 0, discriminant of the quadratic that we get should have repeat roots, and therefore we equate delta equal to 0, or else we write down the equation of tangent and compare coefficients. So we use two methods, either delta is equal to 0 or comparing coefficients. Okay. So now suppose I say, I want to see you maybe, okay, I want to say that line mx plus c, and let us make it more numerical, y is equal to mx, and therefore the line that I am trying to find out passes through origin. And suppose if I give you some parabola, fixed parabola, y square is equal to 4x is a parabola, and y is equal to mx is the line, then it is easy. Is it easy to find out the value of m such that this line is tangent to this? Just do it. What is the value of m for which y is equal to mx is tangent to y square is equal to 4x? M square x square minus 4x is equal to 0. Therefore, x inside bracket m square into x minus 4 is equal to 0. So either x is equal to 0, that is the tangent, or what is this happening? Is it correct? नाही, काय करतोय मी? सॉरी,
tangent y axis ला पॅरलल आहे.
त्यामुळे मग काय होतं इथे? डिस्क्रिमिनंट 0 झालाय का ऑलरेडी इथे? Okay, so let me make it little interesting by doing shift of origin x plus 2. Suppose we do it multiplied 4 times x plus 2, then are we getting two distinct tangents passing through origin? Check. Here it is y-axis, therefore little special case. So if it is y square is equal to 4 times x plus 2, then
सर x minus 2 घेतलं तर ते दोन टँजेंट्स येतील. हा पॉइंट ओरिजिन पॅराबोलाच्या आतच लाय करतो.
ओरिजिन पॅराबोलाच्या आत गेला. बरं, इथे डिस्क्रिमिनंट इमॅजिनरी येतोय का?
हो सर.
लेस देन इक्वेशन.
हो सर.
So m is imaginary. Okay, so in that case let us make it x minus 2. Okay, so in that case this will become plus m square x square minus 4x plus 8 is equal to 0. Delta is 16. इथे प्लस होता, तो आता काय होणार आहे? 16 minus 4 into 8 into m square is equal to 0. So 16 is equal to 32 m square. Therefore, m square is equal to half. M is equal to plus or minus root. So if you follow this particular slope passing through origin, you will get two tangents and you can easily find out the point of contact. Now, suppose I put a condition that this is the curve and we want point of contact at say infinity. In fact, we have found out the auxiliary equation in every case. What was the auxiliary equation in case of parabola? Can somebody tell me what was the auxiliary equation to find out the slope of tangents in case of parabola? Sangha?
Y equal to mx plus a upon m.
Auxiliary equation in case of parabola. Or in case of ellipse is better because it has got all the elements. Ellipse sangha?
Y equal to mx plus or minus root of a square m square.
No, in auxiliary equation form. Auxiliary equation form. X1 square minus a square times m square minus 2x1 y1 m. पुढे इथे काय होतं पुढे सांगा minus y1 square minus b square is equal to 0. बरोबर आहे का इथे काहीतरी मायनस प्लसचा प्रॉब्लेम आहे हायपरबोला y1 स्क्वेअर प्लस b स्क्वेअर आहे अरे हे लक्षात पाहिजे
प्लस इंटू y1 स्क्वेअर मायनस b स्क्वेअर
इथे प्लस पाहिजे आता बरोबर आहे This is auxiliary equation for finding out the slopes of tangent to ellipse from point x1 y1. Okay, so if we put these values over here, we get the equations. We get two values of slopes. Is this equation correct? Okay, let us assume that it is correct and it is minus in case of hyperbola. Okay, so now what I want to ask you is, suppose whatever is this curve and whatever is this point, we want to have the point of contact at infinity. The point of contact at infinity. So what do we do? Think about it.